Hi, very good evening, all of you. Hi, after a you have to wait for long waiting time. You are waiting, and maybe some of the students thought that yes, ma'am is celebrating Durga Puja, so ma'am will not take today's class. But you are wrong. I will be there definitely. I am there for you. So please inform your friend that yes, ma'am is here. So join live quickly join live. Quickly tell them yes, ma'am is live here, and today we will do that complete DBMS. Complete, because those who know me, they are, it is my favorite subject, and this is the request came from so many students previously. Also in the comment section I saw that yes, so that's why I thought today I give a choice, and it was the first choice, so that's why I take that. Okay, let's start first come first serve basis. So those who are here, I want to see this. Yes, who are here? Hi Divya, Deepa and Selvi, Rijana, Ponnila, Saranya. So what you have to do, you know that, I hope so, that share this link, watching this in your all the social media, WhatsApp, Facebook, everywhere, in status. Please add the status, yes, watching this, so your friends can come, and tell your friends to join quickly. I hope I am audible, visible, everything is clear. Is just let me know. And before starting, I can see yes, very good evening, good evening all of you. As we did the software engineering, so here the DBMS will be, we will complete here. DBMS also we are going to complete today, super fast way. Yes, good. Let's start it. Let's start. So here in the DBMS, as per the previous year's analysis, as we are doing always the previous year's analysis, as per the previous year's analysis, you can see the functional dependency, normalization, ER diagram, SQL, B tree, relational algebra. So always 9 to 10 marks questions are coming every year. You can see here was the 6th question from functional dependency and normalization. Functional dependency, DBMS concept, key concept, referential integrity, relational, big data, SQL. Again here in the December 2018, normalization, SQL, data warehouse, indexing, transaction concurrency. So these are the topic always repeated. Now what was the new addition in 2020? These all the topics came same way in 2020 also. In 2021, what is the new addition with this topic? 2021 also normalization was there, and all other topic was also there. With that, another question was there. Actually it is the ER diagram topic only. From the ER diagram, little bit in-depth question. From ER diagram there was 2 question, and another topic is that is the B tree. From the B tree, question came like what will be the number of keys required, that question. So we will do all the question here today. 2020, 2021, all the solution also I will provide you, and with conceptually. First we will start with functional dependency, normalization, minimal cover, everything. We will do transaction, we will do indexing, we will do everything. So let's start it without wasting time. So here these are the topic. You can see most important topic, most important chapter of DBMS. Here I already told you that the B tree was there. So ER diagram, SQL, relational algebra, basic concept of DBMS, data warehouse, indexing, transaction concurrency. If you cover this topic, then after that there is nothing to do. And DBMS is very scoring area, 20 out of 20 is easily you can get here. And this is the area where also again comprehension type question are coming. Already 2 times they ask comprehension type question. One year there was functional dependency, another year there was SQL. So means you can understand from DBMS high chances there you can get again another question. What are the area where you can get 10 marks question in DBMS? This is first of all functional dependency normalization. Next one is relational algebra and relational calculus and SQL. From this area also 10 marks question can come, that is comprehension type question. ER diagram also the area, here also 10 marks question can come. And transaction concurrency also the area where 10 marks question can come. These are the 4 area from where easily they can ask you 10 marks question, means 5 question from one topic. So must do this topic so that your this marks will be, you will not miss this marks. Okay. So can we start? I hope so. Yes everyone, good evening. Mayuri, Meenakshi, Mini, Tamil, Sanju, Priskal, Saranya, everyone. Lekka, previously I told everyone good evening. So let's start the functional dependency. And if you learned with me DBMS, after learning, my lots of students are doing interview and they are getting the job also for functional dependency normalization, because after learning with me it is super easy for everyone. So DBMS will be also easy for you. So here under the relational database model, I am not coming here. These are the relational database model, you already know that. So this is the concepts are very important. 2021 question was there from this concept. 2021 question was there from this concept. Here attribute, table, tuple, relation, degree, cardinality, column, relational instance, relational key, and the attribute domain. What are that? So first of all, attribute means whatever you are writing whenever you are drawing a table. This is the table, right? Here this is a maybe student table. In the student table you are doing the roll number, after that you are giving the name, then all. These are called attribute. And here we are storing the data. These are the rows. These are the columns, right? So in this table only you can see this is the where you are writing the attribute column or attribute. These are the attribute: customer ID, customer name, status. This is called tuple or rows. This is called tuple or rows. Domain, what is domain? Here it is the not null, means here you have to do something. It cannot be blank, it cannot be null. That is called the domain. Primary key means you are setting the constraint here. This is the primary key. When we are setting it as a primary key, it will identify all other attribute, and it cannot be repetitive value. It cannot be repetitive value in a database. Always remember that, right? Now after that, next concept is that what is degree? What is degree and what is cardinality? Degree means total number of attribute in a relation, that is called degree. Cardinality means what? The total number of row present in the table. How many rows are there in the table? That is called the cardinality. So remember it, cardinality means number of rows and degree means number of attribute. Okay. And next one is the relational database, that you all know. So these are the main important points. Okay, clear? Now next one. So here under the functional dependency, these are the functional dependency. How to represent a functional dependency? A implies B. A implies B means here whenever I am writing the functional dependency, it is very important to understand that A can determine B. When I can say, when left hand side, whatever is there in the left hand side, like that. If I am telling that he roll number 1, name is Priyanka. It cannot be possible roll number 1 name is maybe other than that, maybe Sanju. It cannot be possible. So when there is roll number 1, then it have to be a single name. It cannot be multiple name. Okay. So here it is a question for you, how to determine the functional dependency. Here, from here your concept will be clear. Tell me, quickly tell me the answer here. A implies B, hold or not? A implies B, hold or not here? Quickly tell me the answer. A implies B, hold or not here? How to check it? Good evening, Thulasi. Not hold. Acha. How to check it? I am telling you how to check it. Whenever you are able to see that A implies B, this is the left hand side implies the right hand side. First of all, check that in the left hand side is there any duplicate element? In the left hand side is there any duplicate element? If there is no duplicate element, then no problem. Remember always, if there is no duplicate element, then no problem. If there is any duplicate element, then we have to check that with the same element, right hand side also same element have to be do. So here A, these are the duplicate element, A1, A1. Here A1 is telling B1, here A1 is telling B2, it is not possible. When here A1 is telling it is B1, it have to be B1. It cannot be B2. That's why I told roll number 1 name is Priyanka. So next anywhere where is roll number 1, it have to be name is Priyanka. It cannot be any other name. So that's why this is not possible. This is not hold. Same way, if I am going for A implies C, is it holding or not? Now you have to tell me. Is it holding A implies C? Everyone, I need answer from everyone, those who are live here, so that your concept will be clear, your revision will be done. These are the very important concept. Tell me. Tell me quickly. Okay, so answers are coming. So yes, these are the answers. See that A implies C is also not holding. B implies C is also not holding, because A implies C, this one, here is C1, C2. It is also not possible. When you are doing B implies C for B2, B2, here is B2, B2, here is C2, here is C1, not possible. C implies A also not possible. Only for A implies D it will be hold, because where A1, A1, here is D1, D1. That's why there is not a problem. A implies D will properly hold here. That is the understanding what is hold or not, how to do. I hope it is clear. I hope this is clear to everyone. Now again the next question, consider the relation A, B, C. The tuples are given here. Now options, tell me the answer quickly, which is the correct option here. Which will be the correct option where? Here it is the revision series, it is the marathon. So we have to go little bit quickly. Tell me. What will be the answer here? Here it is A implies B, BC implies A, B implies C, AC implies B. Okay, answers are coming. Here BC implies A. It is asking you which does not hold. Does not hold. Your answer will be which does not hold. Please, please, please be clear about the question. You must read the question properly. It is asking you which does not hold. Which one is not holding here? When you are doing BC together, here it is 2, 3, 2, 3. 2, 3 implies 1 here, 2, 3 implies 4 here. It is not possible. This one is not possible. That's why not BC. Yes, that's why it is the correct answer. Please read the question very carefully. Please change your habit. Otherwise, write down that not qualified. Otherwise, remember that you have to see not qualified. If you ignore this not in the question, then you have to be ready to see the not qualified. Now it's your choice what you will do. Okay, now it's your choice. I will not tell anything. Now tell me, this is a expected question. I am telling you this is a expected question. Very important question. Try to do it. Which of the following instance, these are the instant, which of the following functional dependencies hold in the above instance? Very good question. Try to do, and after that I will tell you the answer. I hope those who are watching, you already press the like button. If you forgot to press the like button, then please at least press the like button. I can see till now only 8 like button is there. No one like this class, so you can dislike also. So you can press a like button if you like this class. Otherwise you can dislike also, but press it. Any one of them you can press it. You can press it, any one of them. Okay, so answer is coming. Answer is B. Definitely answer is B here. But it is B implies A. B implies A. Whenever I am checking 1 1, that is 8 8, that is okay. 2 2, that is 10 10. It is asking you that which of the functional dependencies instance. So this is correct. Now A implies B. For same way 8 8, that is 1 1, 10 10, there is 2 2. So this one is also correct. A implies C. When it is 8 8, here is 14, here is 16, not possible. A B implies C. 8 1 8 1, again 4 16, that is not possible. C implies A. 16 16, here is 16 16, and for here 8, here is 10, that's why it is not possible. B implies A. For 1 1, here is 14 and here is 16, not possible. That's why it is also not possible. So only this one is correct. Okay. Okay, clear? Is it clear? Yes? Yes or no? Clear? I hope so. Okay. Okay, now the next. Now we can go for the next. So here in the next, first of all, here it is the what is called trivial dependency, what is called non-trivial dependency. Trivial dependency means self. Always remember. That is A implies A implies AB, like this. When some left hand side and right hand side there is some common thing, that is called the trivial. Non-trivial means when there is no common, nothing, like that A implies B. This is a non-trivial one where there is no common. That is called the non-trivial. So here you can see the trivial, this is the trivial one, this is also the trivial one, this all are the trivial one. Non-trivial, ID implies name, name implies DOB, this is called non-trivial dependency. Theories can also come, guys, so that's why remember that theories can also come. What is transitive dependency? That you all know, X implies Z. When it is X implies Y, Y implies Z, then it is X implies Z, right? Now here is the very important concept between super key, candidate key. This is very, very important concept. And always students are getting confused here. Remember that super key is a combination of key through which you can identify other element. First of all, what is key? When any one attribute or a set of attribute together can identify all other attribute of the table. All other attribute of the table, that is called a key. Now when it is super key, it can be a combination of 2 or 3 attribute together, those who are able to identify other element. That is called super key. Now what is candidate key? Like that, maybe here I am writing AB implies C, D, E, all other attribute. Here is A, B, C, D and E. These are the attribute. Even also maybe here A, D implies also C, D, E. All other attribute including A, B, so definitely will be there. Now I am telling only A can also imply A, B, C, D, E. So here you can see A, B, A, D, these are the super key here. But A is the candidate key here. Because A, AB, AD, everyone can identify all other attribute. But out of them, A is the minimal one. That's why A is the candidate key here. Which one is the minimal? That one will be your candidate key. Clear? Now, which one can be primary key? Here I choose only one candidate key, that is A. It can be possible that A is also able to do, maybe D is also able to identify all others. It can be possible. Then out of A and D, both, any one of them we can choose as a primary key. That is called the primary key, right? So that's why this is the superset subset concept. Candidate key is the subset of super key, and inside there any of them I can take as a primary key. Clear? Theoretical question can come from here, and this is a question for you. Try to do this one quickly. What will be the answer for this? Try to do this one. Sachin, Narmada, Mayuri, Full Moon, everyone. What will be the answer? Until now I can see 32 like. Okay, those who dislike it, you can press the dislike also. If you are watching and if you think that yes, the class is not helpful, then you can dislike also. It's your choice. Yes. What will be the answer then? Tell me. What will be the answer for this? It is a question for you. A, B, C, D. 4 attribute, 4 possible candidate keys are there. These are the candidate keys here. So from here you have to tell me what is the answer. Zarina. Hi Zarina, welcome. Answer, answer, answer. What will be the answer here? And those who want to know the 2020 and 2021 previous year's question solution, PYQs solution, these are all topic wise question solution I am providing here. These are also PYQs. And specifically for 2020, 2021, those who want to know, you have to wait till the end. Must wait till the end. Everything we are going to cover here. All previous year's question, expected question, topic wise, everything we are doing. So till the end, wait for the end so that everything will be done for you. Answer. What will be the answer? Okay, answers are coming here. Yes, this is the answer C. Why? Why this C is the answer? Because see that here is B, here is B, here is AD, here is CD. So B, C and B together cannot be candidate key. If B is my candidate key, then B, C have to be a super key. It cannot be the candidate key. So first of all, I will check with B. B is the candidate key or not. How to check it? What we will do? Okay, I will check that when B is the candidate key, if B implies A, B implies C and B implies D, these all are satisfying, then I can say B is the candidate key, right? So how to check it? First of all, B implies A. Here you can see in the left hand side, these are all different attributes, and I told you in the left hand side, if there are no duplicate element, then there is no concern. With closing your eyes, you can say that it will be always satisfied. So B implies A is satisfied here definitely. Same way B implies C will be satisfied. Same way B implies D will be also satisfied. That's why these all are satisfying, means B can determine this one also, B can determine this one also, B can determine this one also. Means B is my candidate key. When B is my candidate key, then BC cannot be the candidate key. This is a super key because this is the minimal set. With the candidate key, when I can say super key? Super key means with the candidate key plus anything extra you are adding, that is called a super key. So here B plus C you are adding, that's why you got here BC, and this is a super key. So that's why your answer will be this is not possible. Now sometimes students are thinking that ki minimal means they are counting. Don't do that mistake. Sometimes students are doing this mistake that minimal means they are counting, that B is one attribute means this is the candidate key. AD cannot be the candidate key, CD cannot be the candidate key. This is a very bad concept students have. I don't know from where they are learning, but sometimes they are telling me. So always remember guys, minimal means not like that you have to count the attribute. Here B is also the candidate key, even also if you are taking AD together, okay, A is not a candidate key. You can see, if you will see that A implies B, that will not hold, because here is A1, here is A1, here is B1, here is B2. So A is not a candidate key. If you see that D implies C will not hold here. So A is not the candidate key, D is also not the candidate key. But when you are taking together A and D together, then AD will satisfy B also, AD will satisfy C also. That's why AD here is a candidate key, and same way CD will be also the candidate key. So here in this table, A is also the candidate key, B is also the candidate key, AD also the candidate key, CD also the candidate key. This concept please remember. Here students are doing a big mistake. Minimal means not counting. I hope concept is clear. Why these are candidate key? Because only A not a candidate key, only D not a candidate key, only C not a candidate key. That's why together they are making, so that's why I can say they are candidate key. Okay, is it clear? My class will be little bit in depth because we have to learn in depth. Quickly everything is not possible, and DBMS, so definitely we have to learn everything in depth. So I hope it is clear to everyone, and that's why this is the answer, because it is the candidate key. Okay, yes. Now here the question is that identify the primary key. This was the previous year's question, from where 10 marks question came from this dependency only. So I have divided it into conceptually part wise. This is the first part of the question, that what will be the primary key of this table. Do it. What will be the primary key of this table? Do it. Always remember, definitely not is the trap of the question. Previously also you saw the trap. Okay, answers are coming. Yes, answer will be A. Now how to find out the answer? Always there is a easy trick to find out the candidate key. Sometimes students are able to mistake, ma'am, I know how to find out candidate key, but I don't know how to find out primary key. That question are also coming to me. So guys, candidate key means only you are able to find out primary key, because whenever you are able to find out the candidate key, any one of them can be the primary key, right? And if there is only one candidate key, then definitely this is your primary key, right? So how to find out it? There is a easy way, easy trick is there. Write down all the dependency here. A implies BC, D implies E, BC implies D, A implies D. Now check the right hand side. Check the right hand side. In the right hand side, which one is not present? In the right hand side, which one is not present? You have to check that. So which one is not present? You can see out of all other A, B, C, D, E, only A is not present. So candidate key means what? Through that I have to determine all other key. So as A is not present, then definitely A have to be a candidate key, or with A you have to add something else. So here whenever I am doing the closure, this is called closure. A implies A can determine BC. So A, B, C. Now BC can determine D. So D. D can determine E. So E. You can see A can determine A, B, C, D all. And that's why A is your candidate key, means this is your primary key also. Clear? Is it clear to everyone? I hope so. I hope so. It is clear, right? Yes? Yes or no? So these are the functional dependency and attribute closure. What I am telling, these are the closure, how to do the closure. Okay, in this way we have to do the closure, and these are the question already we did it. Now here are some integrity constant. Last class some students was doing mistake in the integrity constant. When I was doing the expected MCQ, then some student did the integrity constant concept mistake. So there are 4 types of integrity constant: domain constant, entity integrity constant, referential integrity constant, and key constant. From here theoretical question, conceptual question can come. Okay. So what is domain constant? What are the different types of constant? Please understand exactly meaning. Domain constant can be defined as valid set of values for an attribute. What are the valid set of values for an attribute? Here when I am writing age have to be integer values. 17 can be possible, these are the possible, but in age I cannot do A. In the age how I can do A? Is it possible? So it is violating the domain constraint here. This is called domain constraint. Valid values have to be there. Next one, entity constant. What is called entity constant? An entity integrity is the set of primary key values cannot be null. Primary key values cannot be null is the entity constraint. Write down this point in your quick revision notebook, because theoretical question, statement type question can come from here. So primary key cannot be null, that is called the entity integrity constant. Here you can see employee ID is null. That is not possible according to entity integrity constant. Okay. Next one is referential integrity. How to do the referential integrity? When you see that one table is making relationship with another table, and this is the primary key here, and this is the foreign key here. Okay, so which one is the parent table? This is the parent table, and you can say this is the child table actually, because whatever primary key is there, I can do the reference these only. In this table, D number is 11, 24 and 13. Out of these only I can insert here 11, that is correct, 24, that is correct, 13, that is correct. 18, how 18 can come here? Because in the main table there is no value for 18, and that's why it is not possible. This is called the referential integrity constraint. Clear? This is violating the rule of referential integrity, because whatever you are referencing, that have to be in the main table. If this is not present in the main table, from where you can do the reference? That is not possible here. Is it clear? Yes. Key constant. What is called key constant? Sometimes students are doing mistake with key constant and entity constant. Here entity constant means key value cannot be null, and key constant means key are the entity set used to identify the entity within the entity uniquely. It have to be the unique value, that is called key constant. Entity constant means it cannot be the null. Key constant means it have to be unique. These are the lines must write down. I am repetitively telling you. High chances there statement type question can come. Which one is this? Which one is that? Even also matching type question can also come. They can give you in the right hand side key constant, integrity constant, domain constant, and this. Here they can provide you something and you have to match, and you will be confused. So that's why exact line write it down. So here you can see 2000, 1002 is here, 1002 is there. These are duplicate value. That is not allowed according to key constant. This is called the key constant. Okay. They can provide you this type of table and they can ask you which constant it is violating. Is it key constant? Is it domain constant? Is it integrity constant? You will be confused if you don't know exact meaning. So please write it down now only. Is it done? Is it done? Yes or no? So what you learn, write it down. After that I will ask you the question. What you learn? 4 types of constant. 1, 2, 3, 4. What you learn in these 4 types of constant? What you learn in the 4 types of constant? What is the meaning exactly? Write it down into the comment section. Write it down. This constant means this is the keyword. What are the keyword you learn? I am asking you to write it down in the comment section. Write it down in the comment section. I am asking that. What you learn? What is domain constant? What is integrity constant? What is key constant? What is referential constant? This 4 point, write it down so that your revision will be done. Because highly expected you can do the mistake. Yes, Dipya is writing, Deepa is writing, everyone. Domain means it have to be valid value, valid. Different data type not, it have to be, different data type also can be, it have to be valid value. Okay, all of you are writing, write it down. So your revision will be done. All the 4, all 4, I am asking you for all 4. And after doing, give me the answer for this. After doing, give me the answer for this. What will be the answer for this? Okay, good, good. Now do this in this. Write down it in this. What will be the answer? Yes, answer will be B. What is the what purpose of applying the data integrity constraint in the database? Improving the data quality, data entered the specific property, that is data integrity. Okay. Yes, now do this question. Here understand this question, understand this concept. From this concept question is there, that question we will do. Here reference table, whenever you are referencing for the foreign key, maintain how to maintain the foreign key and the referential integrity. Like I am telling you, one is the student table, all student, and another is the paid student. Okay, one is the student and another is the paid student, because in our class there are some paid student also. And for this concept also, in means in between, I am telling you what is my WhatsApp number: 8697365460 is my WhatsApp number. Those who want to join the paid course, they can WhatsApp me, so that you can get the complete computer science and paper 1 for UGC NET. You can join the paid course, those who are interested. So here reference table and referencing table. Which one is reference table? Which one is referencing table? Try to understand it. When I am taking student, means all students are here, and out of them some of the students are there who are paid. So this is the superset and this is the subset, right? Now when I am trying to insert, whenever I am trying to insert something in the reference table, means in the student table I am trying to insert something, there is no problem. But if I am trying to insert here in the paid, it can cause violation, because whatever students are there in this table, out of them any one of them only can be insert here. It's not possible that maybe student number 12 is not here, I can insert here. That is not possible. That's why it may cause violation. From here also conceptual question, numerical question, anything can come. Deletion. Whenever I am trying to delete something, means I want to delete one data from the student table, that is the main table. It can cause violation, because maybe I want to delete the student number 10 here, that is referencing here in this table also, paid table also. That's why it can cause violation. So whenever you are trying to delete something from the parent table, then we have to call on delete cascade, on delete set null. What is the meaning? If I am trying to delete something from the parent table, before deleting we have to check the sub table, means referencing table also. In the referencing table, what are the related data, that data you can delete all. After that only you can delete the parent. That is called on delete cascade. Another one, on delete set null, means I am trying to delete the student record 12 from the super class, super table. From the sub table, wherever I will find out student number 12, I will set it the null values there. That is called the set null. So these are the related constraint on delete operation. And here if I am trying to delete anything from the sub table, means maybe previously you was the paid learner, now your subscription over, now you will be deleted from the paid table and you will be there in the all student table. that is not a problem. Easily it can be done, and that's why it is not violating any rule. At the time of updation, maybe student number 12, now you are trying to update roll number as 22. Can I do it? No, because that 12 are referencing either here also. That's why I cannot do it. It can cause violation. Here also it can cause violation, because whenever you are updating something, you have to update both, parent sub table also, super table also. So these are the very important concept. Statement type question can come from here. Whenever you are inserting, deleting, updating, which one can be occur and which one cannot be occur. Is it clear? Is it clear to everyone? Yes or no? Yes or no? Now tell me what will be the answer for this. Tell me what will be the answer for this. What will be the answer for this quickly? Yes, definitely it will be the referential, because here we are doing maintaining relationship, definitely. Now do this one. This is a question. From this question it is asking which one can be the key. Which one can be the key here? Tell me what will be the answer. This is a get previous year's question, and it can be your expected question. It can be your expected question. Do the answer. What will be the answer here? This is given. E, F implies G, F implies IJ, EH implies KL, K implies M, L implies N. These are given here. Now out of them you have to check which one is not present. Just you have to check first which one is not present. Right. So which one is not present here? Which one is not present here? G, I, J, K, L, M, N. I can see E is not present. F is also not present, right? E and F is not present. So that's why I will do EF closer. Whenever I am doing EF closer, I will get EFGHI. So it is not a candidate key. Whenever I am adding EFH, then I am getting this all. Right? I am getting this all. So that's why your answer will be this one. Right? Your answer is D here, B here, right? Yes, clear? Okay, thank you Dibya, thank you. So this is the answer B. It is your answer EFH. Yes, now here it is the another question. What will be the candidate key in this relation? What will be this one? What will be the answer for this one? Quickly do this. Yes, here same way you have to check A implies B, B C implies D, E implies C, D implies A. Which one is not present? A, B, C, D is there. E and H is not present. Easily E, H have to be a part of candidate key. This is not possible. Eliminate it. This is also not possible. Here is EH, here is EH, here is not EH. It is not possible. Definitely it will be my answer. Without wasting your time. Without wasting your time, you can eliminate all these options and you can directly answer it. Just by checking which one is not present, it have to be a part of candidate key, and in other option it is not there, so in this option only it is there, so it will be your correct answer just by checking. Because in exam hall you have to save time, you have to save time. Saving time is very important. Why I will waste my time to check it? AEH is able to do, BH is able to do, DCH is able to do or not? You will do the answer rightly, right? So answer is this one. Now this is the most important chart of normalization. This is the most important chart of normalization, and normalization will be super easy for you when you will learn this. Okay, so I am not going to the chart for quick revision. This is very easy. Those who don't know normalization, it will be also super easy for you. Okay, after whatever I am telling, please understand it, and after that you can go through this. This is a quick revision chart for you. After that you can go through it, and let me add some blank page here. Yes, so how to do the normalization? Remember that how to do the normalization. Normalization, whenever question will ask, then first of all you have to do all possible candidate key. Must do it, because just now in the last question you saw that there was 3 candidate key. So always do the all possible candidate key. Now how to do the all possible candidate key? This is the way how to do the all possible candidate key. What I will do, I can see here EH was not present in the right hand side. I will do plus EH closer. If I am doing EH closer other than EH, anyone is not able to see, E can determine C. That is done. Now after that H is not there, so B, C, C, anything is not coming. Now I will add it one by one. A, E, H plus whenever I am adding. So A, E, H, C was already there. A can determine B. So A, B, C, everything is done. Now B, C can determine D. That is also done. So now A, E, H is your candidate key. Now how to get the other candidate key? For that, what you will check? You have added A. Now from the given functional dependency, you will check that right hand side where is A. In the right hand side, where is A? You can see here is A, means D can determine A. So I can replace A with D. Other than that, everything will be same. Whenever I am replacing the A with D, then I will see that D can determine A can determine B. Now after that EH was already there, E can determine C, BC came, so BC can determine D. That is also the candidate key. Now again check where D is in the right hand side. Now you can see here D is in the right hand side. So I will replace D with someone. Which one I will replace? BC was there. Now you can see E can determine C. So that's why I will not replace with C. I will replace with B here. It is also a decision pointer. Remember that. Here BC was able to determine D. So I will replace D with B or C. Which one? Here is a question mark. Which one I will replace, B or C? That decision you can take with other attribute. You can see E can determine C. That's why as E is there, I can get C. So that's why I will replace D with B so that it can come. That is the decision pointer. You will take B, you will not take C. So I will take B, E, H. Now I will see that. Now see, B, E, H was already there. Now how to determine? E can determine C. So now write down C. Now you got BC. So now you can get D also. Now D can determine A also. So A, B, C, D, E, H all are done. Now is it stop? No. Check B. Is there anyone? Right hand side? Yes, here is the B. A can determine B. Now it is a loop. Here was A. B will be replaced with A. That's why you can stop now. In that way you got this 3 candidate key here. Although this question by elimination we do it, but for normalization it is required to do all possible candidate key. Got it? Is it clear? Yes. So whenever you got all possible candidate key, after that what I have to do? After that I have to do it key what is my prime attribute and what are the non-prime attribute. This is prime and non-prime attribute. Prime attribute means part of candidate key. Non-prime means not a part of candidate key. Okay. What are the prime here? That's why from all possible candidate key, write down it one by one. A, B, D, E, H. These all are the prime attribute. What are the non-prime attribute? That is C. So A, B, D, E, H. Only C is the non-prime attribute. Other than that, all are the prime attribute. Got it? Clear? Clear? Thank you. Thank you, Sharanya. Thank you. Is it clear? Because I believe this revision means not my revision. Revision means your revision. I can do revision in super fast way, so many things together. But if your concept is not clear, there is no meaning. My target is that if anyone is coming to this class for 2 hours or whatever, maybe they don't know anything, but still from this class they can get some marks. They can learn something. That is my target. I will come, I will do everything, and after that students will be not able to do anything. There is no meaning. No meaning. Right? So yes, so non-prime attribute is this one. So this is the first thing that you have to do. Candidate key. First thing, all possible candidate key. Next one, you have to do the list of prime and non-prime. This is most important. Don't do the mistake here. List of prime and non-prime. After that your decision will be very easy. And you have to come from BCNF, then 3NF, then 2NF, then 1NF. This is only in our syllabus. Right? Right? Yes. So what I will do? BCNF means here we will do all left hand side is candidate key. Check all functional dependencies, nothing else is there. All functional dependencies, candidate key is there or not, left hand side. If it is there, it is BCNF. If it is not there, then go for 3NF. For 3NF, what I will do? That non-prime to non-prime is not allowed here. Non-prime to non-prime is not allowed here. Prime to non-prime, no problem. Non-prime or prime to prime, no problem. Got it? For 3NF, these are the things you can remember. Non-prime to non-prime, not allowed. Prime to non-prime, no problem. Non-prime to prime, non-prime to prime or prime to prime, no problem. Okay. In 2NF, here what is allowed? Here non-prime to non-prime is allowed. Non-prime to non-prime is allowed. Here no, it is also not allowed. Whatever here is there, is it allowed or not allowed? What do you think? What it is? Day by day your constraint is going down, right? So that's why this one is allowed here. Which one is not allowed here? Here the problem is, that is prime to non-prime is not allowed here. Okay, this one was not allowed here. Prime to non-prime, here also it was not allowed here. Got it? Prime to non-prime is not allowed here, and here also prime to non-prime not allowed here. Right hand side prime, no problem. Non-prime or prime to prime, no problem. This is also allowed, this is also allowed, but this one is not allowed. Prime to non-prime is not allowed here. Got it? This one was also not allowed, this one was also not allowed, but this one is allowed here. Other than that, everything allowed here. Okay? Partial dependency is this one. This one is called the partial dependency. Partial dependency means, prime means what? Part of candidate key. Part of candidate key. Prime means part of candidate key. That is not allowed here. It is not allowed here also. Non-prime to right hand side prime, no problem. For 3NF and 2NF, right hand side prime, there is no problem. Got it? Clear? Why prime to no not allowed? That is partial dependency, that's why. Got it? That is partial dependency, that's why. Prime to non-prime is not allowed because it is the partial dependency. Okay? A single attribute candidate key is allowed. Yes, that is not only prime. Single attribute is not a prime. Single attribute means it is a candidate key. I cannot say when there is a single attribute in a candidate key, means you are doing candidate key implies something that is in BCNF. Then I can say it is in BCNF. Prime means always part of candidate key. 2NF problem will come. For 2NF, remember that problem will come when the candidate key have more than one attribute. More than one attribute. Then only there is the problem. because then only the prime to non-prime I have to think. If it is only single attribute in candidate key, then no problem, because then here this problem will not come. The total candidate key, it is a single one and it will be definitely in BCNF. No problem. Problem will come when more than one attribute. Got it? So prime is different and candidate key is different. Don't be confused here. Clear? Concept is clear? I hope so. Yes. So that's why here is the chart for you. Here you can pause the video and you can go through the chart. Here this chart is telling this one only, nothing else. Okay? Clear? Yes. Chalo. 3NF only non-prime to prime. 3NF non-prime or prime to prime is allowed. Prime to non-prime. Prime to non-prime not allowed in 3NF also. Prime to non-prime is not allowed in 3NF also. In 3NF also, prime to non-prime is not allowed. Rupa, prime to non-prime is not allowed. Here I am writing prime to non-prime not allowed in 2NF and 3NF both. But non-prime to non-prime is allowed in 2NF but not allowed in 3NF. This one is this and this one is not allowed both. Okay? If right hand side is prime, then no problem. Then no problem for 2NF and 3NF both. Okay? ठीक है? Clear? So that's why here is the question for you. Now do this one. Do this one quickly. Here it is the relation given. How many candidate keys are there and what is the relation? What will be the relation here? How many candidate keys are there and what will be the relation here? Do it quickly. Okay, what are the candidate key? What are the candidate key here? CH implies Z, A implies BC, B implies CFG, E implies A, F implies EG. What are the not here? B, C, A, E, G. Only I can see that D is not there and A, B, C, D, E, F, G and H. DH is not present, right? DH is not present. Other than that, everything is present. Yes. So that's why what I will do, D and H is not present. H, where is H you are getting? Acha, oh, sorry. H was here, right? Yes, sorry. A, G, B, C, H, A, yes, sorry. Yes. H is there, only D is not there. So I will do D closure. If I am doing D closure, anything else is coming? No, nothing is coming. So that's why what I will do, with A I will try. Whenever I am trying with A, then I will get it. So that's why your answer will be here DA, DE, DF, DB. All will come. These all are your candidate key, right? All are your candidate key. And after that you can check as per the relation given. What are the prime attribute? D, A, B, E, H. These all are the prime attribute. What are the non-prime attribute? C, G, H is the non-prime attribute. So here it is coming non-prime to non-prime. CH implies G. That is A, non-prime to non-prime. It is not in 3NF. This is not in 3NF, right? Other than that, this one is in 2NF, this one is in 2NF. But here, when I am doing A implies C, B implies C, these are what? A implies C, B implies C, these are what? It is prime to non-prime, right? This is prime to non-prime. So it is not in 2NF also. So answer will be what? That will be only in 1NF. This is only in 1NF. Okay? Because A implies C, B implies C, these are not in 2NF. This is a partial dependency. That's why your answer will be only this one. Got it? I hope it is clear. I hope this is clear. It is already we have done. Now tell me, identify the normal form from this relation. What will be the normal form for this relation? Same question, this is the next part. Same question, this is the next part. It is in 2NF, guys. It is in 2NF. Here only A was the candidate key. So when A is the candidate key, what I told, there is not a problem. It have to be in 2NF because it is a single attribute. There is no problem in 2NF. It have to be. Now we will check 3NF. So you can see DE. D implies E is non-prime to non-prime. That's why it is not in 3NF. But it will be in 2NF. So answer is in 2NF. Jivita, is it clear? Always I remember that whenever is a single attribute in candidate key, then no problem in 2NF, right? There is no problem. No causing of partial dependency. There is no chance. Single attribute is there. Got it? Yes. Now here is the question. and that is you have to do for the dependency preservation. And when I am dividing it into two parts, then what it will be the answer. First of all, is it preserving dependency? First question, first option is there, and after that these are all normalization. Preserving dependency means what? Whenever I am dividing a relation into two parts, relation 1 and relation 2, after dividing, if I am doing the union, after doing union, am I getting the same FD, same functional dependency? If I am getting it, then this is the correct answer. Okay, then it is preserving, otherwise not. And for that, whenever you are doing, whatever FD is given must do the closure. After that, divide it into relation 1 and relation 2, then do the union of FD1 plus FD2, then check it, am I getting the same one or not. That is called the dependency preserving. Okay, clear? Okay, so answers are coming. So here what you have to do, A, B, C, D, E, these are I am dividing. So when it is dividing, then add this one and this one. So definitely it is dependency preserving. There is not a problem because all the dependency is coming here, no problem. Now problem is that here you can see this is in BCNF because A is the candidate key, this is left hand side is the candidate key, no problem. Here this is coming in BCNF, but D implies E, this is non-prime to non-prime. That's why it is not in 3NF. This is not in 3NF. This will be in 2NF, right? So your answer will be R1 is in 3NF and R2 is in 2NF. It is actually in BCNF. So whenever someone is in BCNF, that is automatically in 3NF also, in 2NF also, in 1NF also, and so on and so on. Okay, yes, so it is your answer. Now this was a 2021 question, you can do it easily. Normalization is a topic from where always question are coming every time. So this is a question of normalization again. Now do that, after that we will go for the next. It is very easy one. It is very easy one. Yes, definitely answer will be this one. Because X, Y, W, Z. What is the candidate key here? X implies Y and this one. So which one is not present? Y, W is present. X, Z is not present. X, Z is my candidate key definitely. Definitely X, Z is my candidate key. Right? So C is correct primary key. And here it is the prime to non-prime. That's why it is not in 2NF. This is in 1NF. So answer will be this one. Got it? Yes. Now do this one. This is a expected question for you. This is the expected question for you. This is the expected question. This is the relation. These are the FDs given, and you have to tell me what is the highest normal form. Now tell me what will be the answer, guys. Answer, you have to tell me the answer. What will be the answer? Yes. So here this rule of RHS will not apply. The rule of RHS is not applied here because everything is present. A, B, C, D, E, everything is present here. So which one is your candidate key here? That you have to find out. So if I am doing A plus, I am getting A, B, C. After that D. Then C, D implies E. That I am getting here. Is it? If I am doing A, B, C, then D, B, D, then C, D is implies E. Everything. Now, if I am doing B plus, is it I am getting B? B, through the B I am not getting. B, D, then after that anything else? No. CD, if I am doing CD, am I getting CD? With the CD you can get C, D, E, A, B, C, everything. So CD is the candidate key. A is also the candidate key. CD is also the candidate key, right? Even also if I am doing E is also the candidate key. You can see E, A. After that from A you are getting B, C. From B you are getting D. C, D is already done. A, B, C, D, E. Everything you are getting. So this is also the candidate key. Right? Yes. Right? And if I am doing that B, C, then you can see B, C, D, E, A. Everything is coming. This is also the candidate key. So A is candidate key, CD is candidate key, E is candidate key, BC is candidate key. All are candidate key here. So which one will be the answer? The answer is in 3NF. Only this is violating here. Other than that, this is also BCNF, this is also BCNF, this is also BCNF. Here only this one is violating here. This one is violating here because here this one is not candidate key. That's why it will be not in BCNF but it will be in 3NF and answer will be 3NF. Clear? Is it clear? That's why you have to check all possible candidate key. Yes, why not BC, guys? If I am taking BC, from the B I can determine D. Now from the D, whenever CD is coming, from the CD I can determine E. From the E I can determine A. Is it or not? Yes. Deepa, yes or no? Can I determine or not? Yes. Clear? Clear? Actually this is violating the only BCNF property. Other than that everything is correct. Because B is also prime, D is also prime. This is prime to prime. It is okay for 3NF. Other than that, all are BCNF. B determine only D. That's why B is not the candidate key. B determine only BD. That's why it is not the candidate key. But whenever you are taking B, C together, B is the prime. That's why I told you. Not, it is not the partial. B implies D. It is also prime. This is also prime. Both are prime. Prime to prime. Right hand side prime. No problem. In 2NF and 3NF. That I told, right? D is also prime here. Yes or no? D is also prime here. Yes or no? Got it? Here you have to check. Right hand side is prime or not. It is prime here. Clear? Is it clear? That's why you have to check all possibility. How to take BC with CD there? Where? Check all the, see that whatever given dependency, check with all the given dependency. Is it a candidate key or not? That is only I check. CD is a candidate key or not, E is a candidate key or not. That is we check. All the possibilities you have to check here. That is we check. Check it. Got it? So we can take from RHS also, ma'am, as candidate key. From RHS means you are taking, if we take BC, then B before prime, correct, ma'am? What are the prime here? What are the candidate key you got here? Candidate key you got here A, C, D, E, B, C. These all are the candidate key, right? These all are the candidate key or not? Tell me. These all are the candidate key or not? Yes or no? These all are able to do. B is not a candidate key. Even also if you see that C closure is also not a candidate key. Right? So that's why what are the prime? If you take not, don't think like that. From all the candidate key, write down one by one. All the candidate key you have to take and write down all one by one. A, C, D, E, B. All are prime here. All are prime. A, B, C, D, E. All are prime. So no non-prime here. There is no non-prime. All are prime. Actually, all are prime here. There is no non-prime attribute. Got it? How BC is candidate key? Because BC together can determine all other attribute. Concept have to be clear. BC together can determine all other attribute. That's why BC is my candidate key. Why not? BC together can determine all candidate key. Right hand side, left hand side, that is not matter. We are applying the trick. Where trick is not applying, there here trick will not apply. Here you have to apply concept. You have to check BC can determine all other attribute or not. BC can determine all other attribute. That's why it is my candidate key. That is simple. My concept, that is simple. Got it? Clear? Clear? Okay. Write down all the list of candidate key, then write it down all are prime here. These all are prime here. Whatever the part of candidate key, A is prime, B is prime, C is prime, D is prime, E is prime. All are prime. Got it? Clear? Okay. So means concept. Concept is very important. Why I am showing this question? Why I am doing in-depth? In-depth study is very important. There is no shortcut of success. Remember that. There are no shortcut of success, guys. In-depth study is very important. If you are not doing in-depth study, then you will be not able to do this type of question. Okay, you have to check. I already told you when I have started the normalization, the first point, that's why I told you this is the first point what you have to do, that all possible candidate key, that is the first point. Then list all the prime and non-prime, that is the second point. Then check the remaining point. That got it? I told first point, why you are ignoring it? I told the first point, why you guys are ignoring it? Don't ignore anything. Please don't ignore anything. I told the first point, list all possible candidate key. If you are not doing all possible candidate key, your answer have to be wrong. You will get a wrong answer. And list all the prime and non-prime attribute. Otherwise, your answer have to be wrong. That is the proof I am showing here. Ki yes, your answer will be wrong. Got it? Clear? All the trick will not apply. Always trick will not apply. We will apply trick wherever possible, but everywhere it will be not possible. ठीक है? Understand it? I hope it is clear. Yes. Yes. So here whenever we are doing the relationship, this find the relationship set, is it equivalent or not? How to check the equivalent? These two FDs are given. How to check the equivalent or not? Functional dependency chapter is a very important chapter and very lengthy chapter. It is the main chapter of DBMS. That's why maybe I am taking little bit more time to discuss it, so that this chapter will be clear for you. After that, maybe I have to arrange another class. That is okay, but clear your concept. Rupa, see that so many questions are coming now. What are the candidate key? A is a candidate key. CD is a candidate key. E is a candidate key. What was the BCNF property? BCNF means, when I can say BCNF? BCNF means when right hand side is candidate key. So A is the candidate key, CD is the candidate key, E is the candidate key. Just now I proved that. So that's why this is also in BCNF. This is also in BCNF. This is also in BCNF. Only this one is violating rule, because this one is not candidate key. That's why this one is not in BCNF. This one will not in BCNF. Right? This one is doing prime to prime. That's why I will satisfy this is in 3NF. That's why answer will be 3NF. Please understand concept. Don't do it like upper. No. Understand concept very carefully. Clear? Is it clear? Anyone have any doubt till now? Yes. It is prime. It is not a candidate key. Other than that, all are candidate key. That I prove here. You can see. Okay? Got it? Got it? Yes. Okay. Chalo. So now tell me how to do. Is it equivalent or not? Is it equivalent or not? Equivalent means you have to check whatever is given here. This all the attribute, all the dependency can you derive from here, and all this dependency can you derive from here. When I can say fd1 equals to fd2, then only we can say these are equivalent, otherwise not. fd1 equals to fd2, then only we can say these are equivalent, otherwise not. Okay, that is the main thing. That is the main thing here. So just do the closure. Try to do the closure. Whenever you are doing the closure, you can see that by doing closure you will be able to do it, and that's why both will be able to do. From here you can see everyone that will be able to do, and that's why it will be the answer that yes, they are equivalent. They are equivalent. Because problem will be only with AB, these are together. BC also here. Only problem is there. Here AB implies D is coming. I have to check from the FD2, can I do AB implies D? Yes, I can do, because here A implies D is there. It is possible. Here is A implies C. Can I do A implies C? From here I can do A implies C. A implies B and B implies C, that is determining A implies C. So that is also done. A implies D, from here I can do, it is A implies D. So both are satisfying, that's why both are equivalent here. I hope I am audible. I hope. Yes. Okay. Now tell me, which one is the redundant here? From the redundancy only you can understand the minimal cover. Yes. How to check it? See that. Here is the thing. Again we have to check the right hand side here. Again check the right hand side. Here is also D. Here is also D. This is also implying D. This is also implying D. Now we will try by removing one by one. First we will remove this one. After removing this one, we have only this 3. Now with that we will check A closure is ABCD, B closure is BDE, BC closure is coming BC. Here was DE, this one is not coming here. Means we cannot remove this one. This is important. We can't remove this. Okay. Now we will try to remove this one. After removing this one, these 3 are here. Using these 3, I am trying to do A closure, I am getting this one, D closure, I am getting this one, BC closure, I am getting this one. Whatever is there, same thing we got here also. All the same thing we got here also. Means AD, after removing this one also I am getting same, means this one is the extra here. This one I can remove. That is the extra one. And that's why AD is the extra one. I can remove this one. This is the redundant one. Okay. So whenever you are removing the redundant one, you are getting the minimal cover. The next question is, which one is minimal cover? Which one is minimal cover here? So which one is minimal cover here? नहीं, सारे PDF नहीं है, पूरा नहीं है. Yes, so minimal cover is this one, because we remove the AD. After removing AD, A, B, C, I can write like that. A implies B and A implies C. This is I can write. But don't do the mistake. If it is like A, B implies C, don't do it A implies C and A implies B implies C. Don't do that. This is wrong. This is totally wrong. Don't do it. The right hand side you can split. The left hand side, when it is together, father and mother both implies child, that you cannot write father implies child, mother implies child. That is not possible. Right hand side you can break, but left hand side you can't break directly. That's why your answer will be this one, and this one is correct. Okay. Left hand side you cannot separate. Yes. So after this here, mainly next another point is there, that is the lossless dependency and lossy dependency. How to check the lossless decomposition and lossy decomposition? For lossless and lossy decomposition, ultimately when it is a complete table, from the complete table, whenever you are dividing into two parts, how to divide, like employee and department, you have to divide in that way, so that whenever you will join these two tables, you should get the table again. That's why one common attribute have to be there. There have to be one common attribute, that is employee ID, employee ID. Other than that, how we will make join? When a family is divided into two parts, there should be a common people who can join the family in two parts. Again, if there is no common people between these two families, then they will never join. Okay. Because of network issue, maybe network issue is going on here, so that's why I have to end the session. So it will be never join. So what we have to do here, main thing we have to check this one. R1 union R2 is equals to R. R1 intersection R2 is phi. That is have to be phi. Means there is not phi, means no, one common attribute have to be there. Common attribute have to be there. After that, what I have to check? R1 intersection R2 implies R2 minus R1, or here is a or, R2 intersection R1 intersection R2 implies R1 minus R2. Any one of them have to be there. So here is the question, you can see ABC, here you ask the FD, you have divided into two parts, AB and BC. Now it is asking that the decomposition is lossless or lossy. How we are checking? First of all, we will do the intersection point. What is the intersection point? B. R1 minus R2. Here is a trick also. Remember that whenever you are doing R1 minus R2, how to do? Whatever is there in R1 minus the common between them. Whatever the common between them. That's why AB, then common was B. So AB minus B, that is A. So now you have to check that B implies A was present or not. If you see, B implies A was not present. This is not present here. Yes or no? B implies A is not present. Another option was there, that was OR. Again we will do R1 intersection R2, that is B. R2 minus R1. Here is BC. Common attribute was B. So BC minus B, I am getting B implies C. So or I will check B implies C. Is it there? You can see B implies C was also not there. That's why this is a lossy decomposition. You cannot get again the same table. It is a lossy decomposition here. Got it? Although there is a common attribute, but this one or this one, any one of them is not satisfying here, and that's why it is a lossy decomposition. Is it clear? Is it clear to everyone? Yes? Yes or no? I hope so. Yes? Clear? Anyone have any doubt? Okay. So now do this one. So here you can see another one, this one. When I am doing here, very carefully do it. A, B, B, C, C, D. We are dividing this one. When I am dividing this one, then you can see this one will be lossless. Because here you are getting common. This one is present here. After that, this one is present here. That's why this one will be lossless. This one is clearly lossless. Okay. So here this is the dependency preserving that I told here. But how to do the dependency preserving? Dependency preserving means F plus F1 union F2, you have to do the closure. Do all the closure. After that only check it. Otherwise your answer will be wrong. Must do closure, then divide it, then check it. Otherwise your answer will be wrong here for the dependency preserving. Okay. So this is a question for you. This is the last question for today. And we have completed the functional dependency chapter with this question. I will take another class if you need. You have to tell me if you need the next classes, because SQL we already did. There is a class on SQL. Previously we did it completely. And I can arrange the class for ER diagram and transaction concurrency and the B tree, B plus tree. These are the things are there. So if you want, you can let me know in the comment section, because it is already 10. Again I have class on 5:30 AM. Every day paid class I am taking on 5:30 AM. So tomorrow also class is there. I cannot continue more because I have to go for sleep also. So after this topic I have to end the session. As per your feedback, as per your requirement, as per your comment, I will decide that what you need tomorrow. Okay, because I cannot do any shortcut. In 1 hour I can complete DBMS, but that will be very shortcut and it will be not helpful for everyone. So that's why I teach in depth, so that at least one chapter will be done, and from this chapter, that is most important chapter, will be done. So do this answer. What will be? Is it dependency preserving or not? What do you think? Is it dependency preserving? And it is lossless or lossy? Next question is that it is dependency preserving or not, and is it lossless or lossy? Two things you have to tell me. Answer, guys. Let me know in the chat box what will be your answer. Okay, answers are coming. Yes. So see, normally if you are checking, you will feel that as I am dividing into AB here and here is BC, here I will get A implies B, here I will get B implies C. So you will think that C implies A will not come. That's why you are telling that it is lossy, right? So that is wrong. You have to do the closure. What I am telling, you have to do the closure. Must do the closure. Whenever this is A closure, you are getting ABC, ABC, ABC. This is the complete closure list. Make the list of completely closure. All possible FD. You have to do all possible FD. Make it the list of all possible FD. After that, then divide it. When you are dividing, you will see that A implies B, B implies A will come here. B implies C, C implies B will come here. And after that, after doing union, now from this one it is coming A implies B, B implies A, B implies C, and C implies A. Concern was with C implies B. Concern was what C implies A, right? So by the transitive property from C implies B, this one, and B implies A, from the transitive property I can get C implies A here. From the transitive property I can get this one, and that's why this one will be dependency preserving. It is correct. This is dependency preserving. Okay, and this one will be lossless also, because just now we did this one. This one will be lossless also. Whenever I am doing this one, this is the different question. So whenever you will do this one, as per this one, here first of all you are taking here AB and here is BC, right? So what is the common attribute? B. So if I am doing R1 minus R2, that is coming what? That is A. If I am doing R2 minus R1, that is coming C. So either B implies A have to be there, or B implies C have to be there. So I can see B implies C is here, means I can join. B implies C is present here, means after doing union I can get A, B, C here. This one is present here. That's why this one is lossless. This one is clearly lossless. Got it? Because here R1 intersection R2 implies R1 minus R2, or R1 intersection R2 implies R2 minus R1. That is satisfying here. This one is satisfying. B implies C is satisfying, and that's why this one is lossless. So it is dependency preserving, yes, and it is lossless also. I hope it is clear to everyone. Yes, yes, clear. Acha, do this one and tell me what will be the answer. This one, A, B, C, D. This one already we did. This is your home task. You can try this one. What will be your answer? You can try it. We did it also. And here answer will be this one, A. Okay. Here is also another question. This is also your home task. You can try. You can try and you will get it. Acha, this one do it. This one quickly do it. This is not your home task. Now only do it and tell me what will be the answer. With this we will end the class. Quickly you can tell me the answer. What will be the answer for this one? Answer me. Answer. What will be the answer? What do you think? Answer. What will be the answer? Yes, as there is no common attribute, there is no common. No common means it cannot be. It cannot be lossless. So your answer will be, here is A and your answer will be definitely this A is correct. That is, it is dependency preserving but not lossless. Not lossless means it is lossy. This one is correct answer. Dependency is preserving because M implies N, P implies Q, that will preserve. But this is dependency preserving but not lossless because no common attribute. Here R1 intersection R2 is phi. It is phi, no common attribute. That's why it is lossy. Right? It is lossy. Clear? Is it clear? Achha, another good question. This is a expected question. So many things are there ready for you and I am trying to end but I am not able to end. Achha, do this one. Do this one. All those students are going but I cannot go because I feel that it's required to study. This is also great question. Do it and tell me what will be the answer. Those who are there till now, please reply. What will be the answer for this one? It is an expected question. Who are here? Just tell me hi. Yes, I am doing. Tulasi, Geeta, Rinki, Purnila, Geeta, Narathan. Acha, what will be the answer? You have to determine the FD. Determine FD here. That is the task, guys. You have to think. Try to determine FD. These are the twist in question. Determine the FD. Determine it. Yes, answers are coming. Some answers are coming. Okay, yes, answer will be decomposition is lossless, because this one we divided into A, B, C and C, D, E. So what is the common attribute? C is the common attribute. I have to do R1 intersection R2 implies R1 minus R2, or R1 intersection R2 implies R2 minus R1. Means I have to get C implies what is R1 minus R2. R1 minus R2 is, this is your R1, this is your R2. C is the common, means I have to get C implies AB, or C implies I have to do R1 R2 minus R1. That is, this is R2, common attribute is C, that is C implies DE. So either C implies AB or C implies DE have to be present here. So check it. This is C. C implies AB. Is it satisfying? Yes, because C is here, no duplicate. We learn here, C, there is no duplicate. No duplicate is here. Means no problem. This is satisfying here. Even also, it will be also satisfied. When there is no duplicate, then this one is also satisfying, and this one is also satisfying. Both are satisfying. So this decomposition will be lossless. Clear? Where which concept will be required? Where which concept will be required, is it clear? Why I was discussing the functional dependency, how to understand functional dependency, because if you don't know functional dependency, you will be not able to do normalization, you will be not able to do the minimal cover, you will be not able to do the lossless lossy. So all questions can be different things, and these are your expected area. These are your expected area. You have to be very clear, very clear, very clear. Okay. Achha, Priya is asking, hi ma'am, could not download the admit card. What might be the problem? Admit card not released till now. Today they did not release admit card. Check it. They will inform the notice. In the notice they will release that for the 8th October we release the admit card. Hopefully 2 days before, means within 6th you will get the admit card and your city allotment notification. Lots of students have so same queries, when we will get the admit card for computer science. You will get the admit card for computer science hopefully on 6th October. Got it? Hopefully on 6th October you will get it. Don't panic. You will be able to download, and I will inform you. I am there, right? I will inform you. Now it is the time to download your admit card. Download it. Okay. Yes. Okay. Yes. So bye everyone. I hope this class will be helpful, and those who did this class till the end, I hope you will be able to do it. Okay. Bye. Bye everyone. Good night. See you again. Your choice of question is so helpful, ma'am. Single question covering almost all the concept. Yes. That's why we are doing less is more, right? That is our target. I will choose the question where it is focusing the concept, right? Good night everyone. Bye, see you again tomorrow. Bye. Bye. Chalo.